Here in the vector integral, the first topic is discussing about the line integral. Line integral is nothing but we can discuss in one dimension. In that, the definition of the line integral is how to we define on which, that is nothing but along the curve. Let r vector is equal to small f of t, define a smooth curve C joining points capital A and capital B. Let ds, that is the small difference, it be the differential of arc length at point P belongs to curve C. Then dr vector by ds is equal to t vector. It is the unit vector along the tangent to the curve C at P. Here t vector is the unit vector along the tangent to the curve C at P point. Let capital F of R vector be a vector point function defined and continuous along C. The component of F of R vector along the tangent at point P is capital F of R dot T vector. Here F and T both are the vector point functions. T is the tangent, unit tangent. F of R is the vector point function that can be defined in a continuous along the curve C. Then the integral F dot T ds, F vector dot T vector ds taken along the curve C is called the line integral of capital F along C. This is written as, and it can be denoted by line integral from the point A to B, F vector dot T vector ds is equal to integral over C, F vector dot T vector is nothing but dr vector by ds into ds. ds get cancelled. It is equal to integral over C, F vector dot dr vector. Therefore, here the line integral is nothing but integral from the point A to B, F vector dot T vector ds is equal to integral over C, F vector dot dr vector. That is nothing but integral. This is a curve C. This is a curve C. We can calculate from point A to B. From A to B, we can integrate. We can find the line integral at particular P point means At particular P point, the tangent line we can draw, that is T vector, and at particular point, the vector point function is F vector. Then the dot product in between of F vector dot T vector into ds is the line integral along curve C from the two endpoints A to B. This is the definite. But curve C is nothing but that is indefinite. We can take for particular definite points to calculate the line integral length. Then that from that too, we can calculate overall length of the curve over C. So that how we can calculate means at particular point P, the vector point function is capital F only, but R vector is the position vector of the curve C. Then dot product in between of the position vector and vector point function is the length of the overall the curve. That is the definition of the line integral. The definition of the circulation means here if V vector represents the velocity of a fluid particle and C is the closed curve, then the integral closed curve C V vector dot dr vector is called the circulation of V vector around the curve C. If the closed curve C of the line integral, if the V vector dot dr vector is equal to 0, then V is said to be the conservative velocity, and in that no work is done and the energy is conserved. Okay. Here, if it is conservative velocity, if it has conservative velocity, then no work is done. If the work is done along the circulation or along the curve means we can find out the line integral of F vector dot dr vector only. Here, if V vector is the velocity of fluid particle and C is a closed curve, then the line integral, or then the integral, it's not line, it's a closed curve. Then the integral over C closed curve over C V vector dot dr vector is called the circulation of V vector around the curve C. If integral over the circulation curve V vector dot dr vector is equal to 0, then the field V vector is called conservative. That is nothing but no work done. No work is done or no work done, and the energy is conserved. That is nothing but if the circulation of V vector round every closed curve in a region D vanishes. Why? Because the end points are same. A is equal to B, then it will be vanishes. If V vector is said to be irrotational. Why? Because the cross product dot dr vector, it should be 0. Okay. Next definition is very important definition. The most of the problems are depends on the line integral of work done by a force. Work done by a force. If V vector represents the force vector. V vector represents the force vector acting on a particle moving along an arc AB. Moving along an arc AB. Then the work done during a small displacement small delta r is F vector dot small delta r vector. Hence, the total work done by force vector F vector during displacement from capital A to B is given by the line integral A to B F vector dot dr vector. You should remember, work done by a force is nothing but the formula is line integral from the limits A to B F vector dot dr vector. Okay. In this, if the force F vector is conservative, what is the relation? It satisfies conservative. Then F vector equal to del pi. Then the work done is independent of the path. In the similar way, if in the case of curl F vector equal to curl grad pi equal to 0 vector and pi is called scalar potential. Already we discussed this one in differentiation. If curl F vector equal to F is a conservative force, then there exists a scalar function pi. It satisfies the relation grad pi. F vector equal to grad pi. Then curl F vector is equal to 0 vector. Then there exists a F vector is equal to del pi. There exists a scalar potential. Pi is a scalar potential. Okay. That is nothing but we can write it as note note 1. If F vector is conservative, force field, if del cross F vector is equal to 0 vector. Second point is a conservative force field is also irrotational. It's also irrotational. Simply you have to remember the work done by a force is nothing but the line integral F vector, that is the vector point function, and the position vector derivative, the dot product in between of the two vectors, line integral is calculated to the work done by a force. If the force vector is conservative means there exists a scalar potential function. It satisfies the relation F vector equal to del pi. When it is independent, the curl F vector is equal to 0 vector, then it is independent. Then F vector is said to be the conservative force. Okay.
Yes, ma'am.
Evaluate integral over C F vector dot dr vector, where F vector is equal to x square I plus y square j, and C is the curve y equal to x square in the plane from origin 0 comma 0 to 1 comma 1. Okay. Here they have given the direct question only, F vector dot dr vector. We know that F vector equal to, given that, let F vector is equal to x square I plus y square j, and r vector, we know that it is in two dimension xi plus yj. From this derivative on both sides, dr vector equal to dxi plus dyj, and find out the dot product in between of the two vectors, F vector dot dr vector, that is equal to x square I plus y square j dot dxi plus dyj. I dot I equal to 1, then we getting x square dx plus y square dy. Why? Because I dot I equal to j dot j equal to 1, I dot j equal to j dot I equal to 0. Okay. Here we can calculate integral over C F vector dot dr vector is equal to integral over C x square dx plus y square dy. Okay. Here the whole function can be reduced to either x variable or y variable by giving the related curve to that particular vector point function. Here we know that y is equal to x square, and the derivative on both sides dy is equal to 2x dx. From this y equal to x square, here y square dy, if we want to change the y variable to x variable, means in the place of y square we can write it as x power 4, in the place of dy equal to 2x dx. Then integral over C F vector dot dr vector is equal to integral over C x square dx plus x to the power of 4 into 2x dx. It is equal to, here, integral over C x square plus x power 4 into 2x is, that is 2x power 5 whole dx, and the plane y equal to x square, it is in the plane of from 0 comma 0 to 1 comma 1. So here we can take the plane moves from 0 comma 0 to 1 comma 1. That is nothing but, in this the y variable can be changes to x variable, means we can take the limits x, that is nothing but x limits from 0 to 1. If you want to change the limits of x to y, means you can take in the place of x square equal to y, you can change, then dx equal to 1 by 2x dy. That is nothing but 2 root x. For that, y limits also 0 to 1. It is equal to integral 0 to 1 x square plus 2x to the power of 5 into dx. Next, here integral over C F vector dot dr vector is equal to x squared integration is x cubed by 3 plus x to the power of 5 integration is x to the power of 6 by 6. Limits from 0 to 1 only. Here C is nothing but plus C minus C get cancelled. It is equal to 1 by 3 plus 2 ones are 2 threes are 1 by 3 minus 0. Here 1 by 3 plus 1 by 3 is nothing but 2 by 3 units. Therefore, integral over C f vector dot dr vector is equal to 2 by 3 units. It is a solution. Second question, second type. Find the work done by a force f vector equal to 3x square minus 6yz into I plus 2y plus 3xz into j plus 1 minus 4xyz square into k. In moving particle, from the point 0 comma 0 comma 0 to the point 1 1 1 along the curve C, in that x equal to t, y equal to t square, z equal to t cube. Here find the work done by the force. What is the relation of the work done by the force? The work done by the force F vector along curve C is equal to integral over C F vector dot dr vector. You should remember this is as a formula of the work done by a force along the curve C. First, we can take the given vector. F vector is equal to what is that? 3x square minus 6yz into I plus 2y plus 3xz into j plus 1 minus 4xyz square into k. This is a force vector and it force vector moves from one place to another place, that is a is equal to 0 comma 0 points and b equal to 1 comma 1 comma 1, and the curve C can be defined with the variables into another variable, that is x equal to t, y equal to t square, z equal to t cube. In this f vector, the line integral over C f vector dot dr vector means the function after the dot product of the two vectors, we are getting the x, y, z variable function. In that, we can transfer the variables into one variable. Already they have given x equal to t, y equal to t square, z equal to t square. Sorry, it is t cube. The curve is defined in the variables into only single parameter, that is single variable t. Now we are differentiating of those variables. X equal to t means dx equal to 1. Y equal to t square means dy equal to 2t dt. Here 1 dt. Here dz is equal to 3t square dt. These are the values. We know that the position vector r vector equal to xi plus yj plus zk. Taking derivative on both sides, dr vector equal to dxi plus dyj plus dzk. The dot product in between of the two vectors f vector dot dr vector is equal to 3x square minus 6yz into I plus 2y plus 3xz into j plus 1 minus 4xyz square into k dot dxi plus dyj plus dzk. The dot product in between of the two vectors means we are getting 3x square minus 4yz into dx. Why? Because I dot I equal to j equal to k equal to 1. I dot j equal to j dot k equal to k dot I equal to 0. The dot product. I dot I it is dx plus 2y plus 3xz into dy plus 1 minus 4xyz square into dz. Now we can substitute these values x equal to t, y equal to t square, z equal to t cube and its derivatives in this function, that is f vector dot dr vector equal to 3t square minus 6t square into t cube dx is nothing but dt plus 2y is nothing but t square plus 3 into t cube y is 2t dt plus 1 minus 4 into t square into t cube whole square dz is 3t square dt. It is equal to dt is common from all the terms that can be the right side of the bracket 3t square minus 6 bases are same, then we can add the powers t power 5 plus 2 2s are 4 t square into t is t cube plus 3 2s are 6 1 plus 3 4 plus 1 5 t power 5 plus 3 ones are 3t square minus 3 fours are 12. It's 1 plus 2 plus 3 2s are 6 plus 2. It's 11 t power 11 into dt. Okay. Here any terms will get cancelled. 6t power 5 minus 6t power 5 both will get cancelled. Here 3t square plus 3t square. It is
Yeah,
nothing. We can add it. 6t square plus 3 4t power 4 only single term 4 t cube sorry. Here minus 12
minus 12 t to the power
t
4.
power 11 into dt. Now we can take the points a is equal to 0 comma 0 comma 0 and b equal to 1 comma 1 comma 1. Just you can take it is x y z x y z. Here x equal to t, that is t starts from the t limits are t equal to 0 to 1 is the limit of t. Okay, why? Because t equal to 0 t equal to 1 t equal to 0 t square equal to 1, that is nothing but t equal to 1 t equal to 0 t cube equal to 1, that is nothing but t equal to 1. In all variables are reduced to single variable, then the limit values are also 0 to 1 only. If 1 square is 1, 1 cube is 1, so t limits are 0 to 1. That is the main. Here integral over C f vector dot dr vector is equal to integral t equal to 0 to 1 f of t dt. Therefore, work done by a force f vector along C is equal to integral over C f vector dot dr vector equal to integral t equal to 0 to 1 small f of t dt. It is equal to t equal to 0 to 1 6t square plus 4t cube minus 12t power 11 whole dt. 6 into t cube by 3 plus 4 t power 4 by 4 minus 12 t power 12 by 12. Limits from 0 to 1. 4 ones are 4 ones are 12 ones are 12 ones are 3 ones are 3 twos are. Apply the upper limit. 2 into 1 plus 1 minus 1 minus all zeros. T variables are zeros. It is equal to plus 1 minus 1 get cancelled. 2 units. Therefore, integral over C f vector dot dr vector equal to 2 units. The work done by a force F vector along C is also 2 units. It is the solution.